In this video, I'm going to discuss the power rule for exponents. So the power rule states that if I have x to the power of m and then raise that whole thing to the power of n, really I could say x to the power of m times n. So essentially I'm taking these two exponents and I'm going to multiply them together. So that works anytime you have an exponent raised to another exponent. So let's take a look at an example using numbers. So if I have 3 squared, and I'm going to take that to the power of 4, based on a definition, that should be the same as 3 to the power of 2 times 4, which is 3 to the power of 8, because 2 times 4 is 8. However, can I look at that the long way and take it in expanded form? Well, if I have 3 squared, and that's going to be to the power of 4, won't that be 3 squared times 3 squared times 3 squared times 3 squared? And now I have this 4 times. Taking that one step further, wouldn't each one of these 3 squareds be 3 times 3? So when I write all these out, how many 3's do I have that I'm multiplying? 1, 2, 3, 4, 5, 6, 7, 8, which I knew was the answer, 3 to the power of 8. Moving right along, let's look at a few examples of the power rule whenever we're using variables instead of numbers. So in this first one, we have y to the 4th, and that whole thing is raised to the power of 5. So by using the power rule, we're going to take this 4 and the 5 and multiply them, and we're going to get y to the power of 20. And that's our final answer. So our next one we have is x to the power of negative 3, and that whole thing is raised to the power of 8. So again, we'll take this negative 3 and the 8 and multiply them, and we get x to the power of negative 24. However, we don't like to have this negative exponent, so we're going to put it from the top, and we're going to put it on the bottom and make it a positive exponent. So it's really 1 over the x to the power of 24. So the next one is a to the power of negative 10, and that whole thing is raised to the power of negative 2. So again, we see there's lots of negative exponents up here, but we're still just going to multiply, and negative 10 times negative 2 is going to make a to the power of positive 20, and that's our final answer for that one. Our next example has a quantity here raised to the power of negative 2, and it's going to be x to the negative 3 times x squared. So, using our product rule, we can go ahead and put these x's together first and say negative 3 plus 2, and that's going to be x to the negative 1, and that's all raised to the power of negative 2. So now when we use this property, we can multiply these two right there, and negative 1 times negative 2 makes x squared. So this example simplifies down to just x squared. The next example has a fraction inside here, and that whole thing is raised to the power of 3. It'll be y to the 5th divided by y squared. All that is going to be cubed. So in this case, we can use our quotient rule first, and we can say 5 minus 2, and that'll be on top. So it'll be y cubed, and that whole thing is cubed. Now we can use our rule and say 3 times 3, and our final answer for this is y to the 9th. One more example, kind of the same thing as the last one. We're going to use the quotient rule here and say 9 minus a negative 3. So let me write that all out. 9 minus a negative 3, and that whole thing will be raised to the power of negative 2. So, continuing on, 9 minus a negative 3 will be m to the 12th, all raised to the power of negative 2. So moving right along, 12 times negative 2 will be m to the negative 24th, but we don't like to have that negative exponent, so we're going to drop it down and make it 1 over m to the power of positive 24. And that's the final answer for that final example.